a bullet is fired and it has mass m and speed u into a fixed block of wood and is brought to rest in a distance s, find the resistance to motion, assuming it to be constant. Okay, so we have speed u, it's brought to rest. So no numbers in this question, we're just dealing with variables. So we will need to find acceleration. For now it's equal to a, and the distance in this case is s. So we can use v squared is equal to u squared plus 2as here. That will give us a in terms of the other variables. So 0 is going to be u squared plus 2as. So a is going to be minus u squared over 2s. So that's just acceleration in terms of u and s. So the resistance to motion, F, is equal to ma. So in this case, it's just m times minus u squared over 2s. So minus mu squared over 2s is this resistance to motion. We could call it R if you wanted. So then another bullet of mass m is fired with speed 3u. So now we have u is equal to 3u. And another block which has thickness 5s, s is equal to 5s. Find the speed with which the bullet emerges. So we have a velocity at which it emerges. And we're told the same resistance. So a is going to be the same here. Minus u squared over 2s. We're going to have v squared again is equal to u squared plus 2as. V squared is equal to 3u, let's change speed to v squared, plus twice minus u squared over 2s times s, the 2as. You can see the s's and the 2's will cancel. No, sorry, it's 5s this time. I should have had a 5 here. 5s, so we're going to be left with v squared is equal to 9u squared minus 5u squared. V squared is equal to 4u squared, which gives v to be 2u. 2u by 2u is 4u squared. We're asked to get the time as well, so v is equal to u plus at. We should have all the variables to get this. So v, my 2u, it entered at 3u. My acceleration is minus u squared over 2s, and I need to get time in terms of these other variables. So if I divide across by u, I'm going to get 2 is equal to 3 minus u t over 2s, and if I bring that to the left and the 2 to the right, I'm going to get ut over 2s is equal to 1. So t is equal to 2s over u, the time taken to emerge. We move to question 12. A golf ball of mass 1 over 7 kilos falls vertically and lands at a speed of 1.4 on a marsh. If resistance of the marsh to motion is of magnitude 2.1, find the depth to which the ball S will penetrate the marsh before coming to rest. So if we start with a diagram, here's my golf ball. It's falling, always with mg. There's a resistance here, and the resistance is 2.1 newtons. So the mass is 1 over 7. So 1 over 7, and gravity is 9.8. So that's going to give me 1.4. So I've got a 2.1 and a 1.4. So my resultant force is equal to, and it's falling in this direction, so it's going to be 1.4 minus 2.1, which is equal to minus 0.7 newtons. And we know this resultant force is equal to ma. So this will give us acceleration. Minus 0.7 is equal to the mass. We can leave it at 1 over 7, I'd say, times acceleration. So minus 4.9 ms to the minus 2 is going to give me a. So now second diagram, it's hitting the ground. So we imagine this golf ball, it's coming down. It's hitting the ground here, and it's going to penetrate, let's say, to this depth here. So what's happening at this point? It's come to rest. We have the acceleration of minus 4.9. We know the speed it's traveling at because it lands at a speed of 1.4. So it hits at a speed of 1.4, and we're asked for this. So VUAS, we can use V squared is equal to U squared plus 2AS to see how far this golf ball goes down. So it comes to rest. It hits at 1.4 and twice minus 4.9 by S. So we're going to have 1.4 squared divided by 9.8 is going to give me S. So this golf ball is going to penetrate 0.2 meters or 20 centimeters if you're asked for it in centimeters. We're not asked for either, so either answer here. Question 13 and 14 still to come. A particle of mass 10 grams falls from rest from a height of 2.5 meters onto a soft material into which it sinks 0.35 meters. Neglecting air resistance, calculate the constant resistance of the material. Constant resistance of the material. Okay, we'll do a diagram here beside it. I'll write my variables now. First, I have my mass, I have my height of 2.5. I have starting from rest. I don't know the speed at which it hits the ground, which I'm going to need. We saw that from the previous question. And my acceleration, it's falling from rest through the air. So acceleration here is going to be gravity 9.8 meters a second. So VUAS, I can use V squared is equal to U squared plus 2AS here to get the speed at which it hits the ground. So V squared is equal to U squared plus 2AS is going to give me V squared is equal to my 0, starts from rest. So V squared is equal to twice 2.5 by A. So V is going to be the square root, no, V, excuse me. I have my 9.8 for my A. So 5 by 9.8. It's going to give me 49. So that's going to give me V is equal to 7 meters per second. So that's the speed it hits the ground at. So that's exactly what's happening with the golf ball here. The diagram beside it, it hits the ground here at 7. How far down does it go? It tells me 0.35. So we have V, we have S is 0.35. It comes to rest, so that V is equal to 0, so I can change the speed it hits at to a U. I'm going to go back up there now. Obviously that's part of the previous formula, so I shouldn't do that, but we have U is equal to 7. So I need my acceleration here. Again, V squared, same formula, is equal to, so 0, V squared is equal to U squared, 7 squared plus twice 0.35 by A. So we're going to have acceleration here is going to be 49 divided by 0.7. That's going to be a minus, and that's 490 over 70. So A is equal to minus 70 ms to the minus 2 here. And what are we asked? Neglecting air resistance, calculate the constant resistance of the material. Where we're going to have to bring in then force is equal to ma here. I'm just going to do a little sketch here as well. So here it is falling. This is mg, and the mass which we haven't brought in yet is it's 10 grams. 0.01 is 10 grams. 0.01 g, which is 0.01 by 9.8, which is 0.098. We have resistance here. So now I can can get my resultant force, it's going down in this direction. So 0.098 minus R is my resultant force. That's equal to MA. And we have the M is 0.01, and we have A over there to be minus 70. Minus 70. So that's going to give 0.7 on the right hand side. So if I bring R to the right and add 0.7 to this, I'm going to get 0.798 is equal to R.